Not many people know how wells and water systems work. So let's take a look at the key parts that make up a typical home water system. First is the well itself, a shaft or deep hole in the ground extending down into the water-bearing formations. The average well is about 200 feet deep, and most are drilled by specialized drilling equipment. Casing must always be placed in the top part of the drilled hole to prevent the risk of surface water getting into the well. In some types of rock formations, casing may extend much deeper to prevent the hole from caving in. Some wells use a well screen to let water in and to keep sand out of the well. A pump is needed to get water out of the well and into the home. Water from the aquifer is pumped from the well into a pressurized tank, which stores water for use when the pump is not running. From this distribution point, water is piped to individual use points in the home. The planning, design, and construction of a water well and home water system needs to take account of geology and environmental conditions at the building site. The first step is proper planning. How much water is required to meet the needs of expected water usage in the home and garden? Where should the well be drilled? What well yield will we get? What water system equipment may be needed to provide a reliable supply? The builder or homeowner should get expert advice about the availability and reliability of local groundwater and the safest place for drilling before the first dirt is disturbed. This is the time most prospective well owners turn to experts. The drilling contractor will have current information on any state and local environmental restrictions and permits required for drilling, as well as mandatory construction standards for water wells. The driller can recommend the best place for a well based on the character of the soil and bedrock and the required distance from other structures or possible sources of contamination. A water well contractor with extensive experience in the area will have records of previously drilled wells. These records provide helpful information on the location, depth, and typical water yields from nearby wells. In low-yielding rock formations, a well probably will need to be several hundreds of feet deep in order to provide adequate supply. But a well yielding as little as a half gallon a minute can still provide 700 gallons a day, more than enough for a family's needs. Homeowners need to know the capacity of their well. Virtually all wells will provide enough water for in-house needs, but not all wells can support garden and lawn irrigation systems. Back in the early days of rural settlement, water wells may have just been hand-dug holes in the ground. Today's water wells use modern technology to efficiently reach the aquifers, and contractors use accepted well construction methods to ensure that the well is safe from any surface contamination risks and will give the best yield available from the formations. Several techniques are used to drill water wells. The most common is the rotary drilling method. Other methods are cable tool, jetting, and driven well points. In rotary drilling, a drill bit is attached to a string of drill pipe. As the drill string is rotated, the bit acts as a grinding machine. Cuttings are flushed upward and out of the hole by circulating a special drilling fluid called drilling mud down through the drill pipe and back to the surface. This drilling fluid also serves to cool and lubricate the drill bit, and by stabilizing the wall of the hole, it can prevent possible cave-in before the casing is fitted into the hole. In areas of hard rocks, many drillers prefer to use a rig that operates by compressed air to operate a downhole air hammer to break up the hard rocks. The compressed air also blows the crushed rock fragments to the surface and any water that flows into the well during drilling. Another drilling technique uses a pounder machine, usually referred to as a cable tool drilling rig. With this method, a heavy bit is attached to the end of a wire cable, is raised and dropped repeatedly, pounding its way downward. Periodically, cuttings are baled out of the hole. The method is slow and in most places has been replaced by rotary drilling. The cable tool method is responsible for millions of successful wells around the world. No matter which method of drilling is used, The hole is usually lined with steel or plastic pipe called well casing. The type of casing used is determined by local geological conditions and the chemical quality of the groundwater. In most states, there are recommended well construction standards. Diameter of the drilled hole is usually an inch or two wider than the diameter of the casing. The space between the drilled hole and the casing has to be filled to prevent surface water from migrating downward along the outside of the casing and contaminating the aquifer. This filling is called grout, and it may be either cement or a special clay called bentonite. Sometimes, most of the space is filled with fine rock pieces from drilling, and then the top 20 feet is grouted with cement or bentonite. If the well is drilled into rocks that are crumbly or into sands and gravels, a well screen probably will be needed. The well screen is a sieve or strainer-like cylinder attached to the bottom of the casing. It allows water to flow into the well while preventing fine rock particles or sand from entering. Well screens are not all the same, and the well driller will select the opening size of the screen depending on the size of the rock fragments or sand that make up the aquifer. With the casing and well screen or other intake in place, a flushing or backwashing of the well may be performed to eliminate loose fragments and stabilize the area immediately adjacent to the well intake. This is called developing the well. Water is pushed from the well to the surface by a pump. For deeper wells, and those at least 3 inches in diameter, an electric submersible pump is usually installed directly in the well. The electric motor turns impellers in the pump, which cause water to be pushed upward out of the well. In some wells, especially in narrow diameter holes where the depth to water is less than 25 feet, a shallow well jet pump may be used. Above ground deep well jet pumps, also driven by electric motors, cause water to be pushed out of the well. Jet pumps have to be protected from frost, and in northern states are often placed in a home's basement. Most home water systems include a water storage pressure tank, usually located in the basement or utility room. An important purpose of the pressure tank is to keep the supply of water to the home's taps and fixtures at a fairly even pressure. The pressure tank also stores several gallons of water, so if you only use a small amount, for example just filling a glass, the pump doesn't have to run during that time. A pressure switch controls the starts and stops of the pump whenever water pressure drops below a preset level. The pressure in the tank is restored each time the pump runs. To show how a typical water system works, let's follow a drop of water on its journey from the aquifer to the home. Here is the water drop deep underground. It has been moving slowly through the formations for a few years since it first entered the ground as a raindrop. Right now, there is very little movement of groundwater in this aquifer. Now, what happens when the tap is turned on? At first, the water comes from the pressure tank where it is stored, but as more is used, the pressure switch starts the submersible pump. When the pump switches on, our water drop moves from cracks and fissures in the formation, through the well screen, and into the well. Once in the well, the drop is slowly drawn upwards toward the pump. It passes through the pump intake and is swirled around by the pump impellers and pushed up a pipe. It travels up the pipe into the house. Once it enters the house, it goes into the pressure tank. Then it may temporarily stop if the people in the house have turned off the tap because no more water is needed at the time. Now the tap has been turned on again. The water drop flows out of the pressure tank and through any water conditioning equipment, in this case, a water softener. The water drop passes through the softener, enters the plumbing system, and emerges at the kitchen tap, from aquifer to coffee maker in the space of a few minutes. Homeowners need to check their water systems from time to time. An annual water test is a good idea, and most water labs will provide sample bottles and instructions. Every few years, a professional contractor should be called in to check that the pump, pressure tank, and conditioning equipment, if you have any, is working efficiently.